In this video, we are going to discuss about the some design process variable used in the atmosphere distillation column, like nature of crude, flash zone, and flash zone temperature and pressure. So the process variable, the first one is the nature of the crude. So this is very important thing, like water content, metal content, heat stability. The heat stability of the crude limits the temperature to which crude can be heated in the furnace without incipient cracking. So overall, we have to go through the crude assay to find out the crude quality of the basically crude quality, so that we can use this crude assay in the designing of the atmosphere distillation column. And the second important variable is flash zone operating conditions, which include both temperature and pressure. These are two things. So we know about the flash zone, that is a location where the feed is entering. So that is a flash zone. So as far as the temperature is concerned, flash zone temperature is concerned. So flash zone temperature is limited by the advent of cracking. It means that we can choose the maximum possible temperature that should be safe, and at that temperature cracking should not be started. So before the cracking means before the cracking of the heavy hydrocarbons, the temperature we can maintain at the flash zone, because if we increase the temperature, more and more high temperature is always desirable. If more high temperature is there, more percentage of the feed will be liquefied, so that will be vaporized, sorry. So that is our requirement. So that's why we need to have a high temperature. As far as the pressure is concerned, flash zone pressure is concerned, so flash zone pressure is set by fixing the reflux drum pressure and adding to it the line and tower pressure drop. So total pressure drop we have to add, then find out the pressure at the flash zone. So this in this way we can find out the pressure in the flash zone, and we have to calculate it. For example, this is a simple diagram for the atmosphere distillation column. This is the flash zone, so this is our target. We have to find out the pressure in this section, and our reference pressure is always started from reflux drum, means say 1 atmospheric pressure is at the reference drum. So always there is a pressure drop continuously. From this point to this point there is a pressure drop, means here the pressure should be higher than the 1 atmospheric, so that the these vapors and this liquid can be flow up to the reflux drum. So there should be a pressure drop between these 2 points. Similarly, from this place to flash zone there should be a pressure drop. So this is also a pressure drop. So all these pressure drop has to be calculated, and then we can find out the pressure at the flash zone. So for example, the normal range of the reflux drum pressure is about 0.2 to 1 psig. So it means that it is 1 atmospheric pressure. Psig means gauge value, so it is very close to the atmospheric pressure. The design pressure drop across the condenser associated pipe should be 5 to 7 psi. So we can say between these two points, there is a pressure drop of 5 to 7. So from this point to this point, delta P is 5 to 7 psi. And then the most atmospheric have 25 to 35 trays. These trays between the flash zone and the tower top, between these two portions. So we can say that from this portion to this portion there are 25 to 35 trays, and per tray there are pressure drop from 0.1 to 0.2. This is a pressure drop for per tray. So we can find out just by multiplying number of trays and pressure drop from each tray. For example, let us assume the pressure drop between these one is psi, 5 psi. So from this point up to this point, this pressure drop is 5 psi. This is approximate value. So at this point the flash zone pressure is set at the sum of the reflux drum pressure plus the combined pressure drop across the condenser plus the tray above the flash zone, pressure drop due to the tray above the flash zone. So this way we can find out the pressure. So this is, for example, 1 psig at reflux drum plus 5 psi pressure drop at these points, and plus 5 psig pressure drop along the due to the trays. Total is equal to 11.0 psi gauge. So it's slightly higher than the value of the 1 atmosphere. You can say slightly, exactly means about 14 psi is equal to the 1 atmospheric. So it is near about 1.75 atmospheric pressure. A pressure drop between 5 psi between the flash zone to furnace outlet. Between these two, we can assume the pressure drop of 5 psi. So we can say that this is the pressure, highest pressure here. The pressure drop between this one, then again pressure drop, then again pressure drop, and if you reach the reflux zone, that will be approximately 1 atmospheric or the 0.2 psi G to 1.0 psi G. So in this way, we can find out the pressure drop. The method that I have described here, that is a way to find out the pressure that is possible in the flash zone. The possible questions that is in this lecture is how pressure at flash zone is calculated, what are the process variable required for material balance and atmosphere distillation column. So these are the different process variable. Explain how to fix temperature and pressure at the flash and atmosphere distillation column. So these are the few questions that can be basically arises during this lecture. Thank you very much.